Hello, hello, hello. All right, we're going to move on to the next conic. This one is called a hyperbola. So this looks different, very different from, the graph looks very different from an ellipse and a circle, but the equation looks really close to an ellipse, and so there's only one distinguishing feature. All right, so how do I recognize the equation of a hyperbola? That's one objective, as well as how do I recognize if it's a horizontal hyperbola or a vertical hyperbola. Then we're going to write some equations off of the foci, the vertices. How do I look at an equation and find the vertices, find the co-vertices, find the foci, find the asymptotes, and then we're going to do some sketchy business here. All right, so equations of hyperbolas. Okay, so let's pop down to the equation first. We have x squared, sorry, we have x squared over a squared minus, circle it. That's your distinguishing feature between an ellipse and a hyperbola. Circle that. Y squared over b squared is equal to 1. Okay, so the only difference between the equation of an ellipse and a hyperbola is the minus sign, okay, when you're looking at it. Now, here's another difference, okay. Your a squared, it doesn't depend on which one is bigger or smaller. A squared is always under the positive variable. So a squared is not under the variable that follows the minus sign. A squared is under the positive variable. You see how x squared is positive here? Okay, a squared is always under the positive variable. Okay, the primary axis is not called a major axis, it's called the transverse axis. And when a squared is under x squared and x squared is positive, then it's a horizontal hyperbola. The vertices, notice that a squared is under x squared. Look, a is in the x spot again. All right, a is in the x spot. This is negative a and positive a. That's the square root of a squared. The co-vertices are in the y spot. How come? Because b squared is underneath y squared. The foci are in the x spot because the foci are still on the same axes as the vertices, so they're still going to be in the x spot. And then notice the difference here in this. When we had an ellipse, c squared equals a squared minus b squared. Notice that we have a squared plus b squared. All of this is driving because of this minus sign right here. And then we have things called an asymptote. I'm going to explain that in just a minute, but it's the co-vertex divided by the vertex. That becomes your slope, and then times x. Okay, there are equations of lines. Okay, if it's a vertical asymptote, then a squared is under the y squared, because look, y squared is now the positive term. Y squared is now the positive term. The negative is in front of the x squared, okay? This is going to make your transverse axis, or the primary axis, the vertical one. The vertices are going to be in the y spot because a is underneath y. The foci are going to be in the y spot because a is underneath y, a squared is underneath y squared. We're going to find the foci by using this equation, okay? And then the asymptotes are plus or minus a over b times x. These are equations of lines, okay? It's going to be a little bit more, it'll help when we start doing the picture, okay? So let's do a horizontal. So I want you to keep looking back at that slide 2, the one that we just came from, okay? So when you have a horizontal ellipse, okay, that means that your x squared term is the one that's going to be positive. and that a squared is going to be under that. Okay? All right. So the first thing we have is what's called a transverse axis. Okay? And the the vertices lie on that transverse axis. They're not the endpoints anymore. Well, they kind of are. They're endpoints of something different, but not the axis itself. Okay, so the vertices lie on this transverse axis. What else do you think lies on these transverse axes? The foci. The foci lie on these transverse axes. Okay, and then we have what's called the conjugate axes. That's what created from the endpoints of B. Okay, and then here's how we use the vertex and the covertices. What we do is we sketch this, oops, wrong way. We sketch I use a dotted line. We sketch a rectangular box. Okay, this box is going to help us actually sketch the graph of our hyperbola. Okay, so once you connect your vertices and your covertices with a rectangular box, okay, then what we're going to do is we're going to draw in these diagonal lines. Those are your asymptotes. They go from corner to corner. They're the diagonals of your box, your rectangular box. And because this is horizontal, we have the slope is going to be b over a and negative b over a. So this is a positive. This one is a positive slope, and this one is a negative slope. And it's always going to work that way. Okay. Now what we've done is we have created branches that our arms are going to get close to but not touch. So let me show you how this works. So now this is your actual hyperbola. This is your actual hyperbola. Notice that your foci sits between the arms of your hyperbola. So this is between the arms, okay? Between. And then we have another hyperbola on the other side, sorry. So the hyperbola are these two purple branches, okay? So I'm just going to go through that one more time. All right. So we have an x squared over a squared minus y squared over b squared. We have a transverse axis that holds the vertices, okay? That also holds the foci. The foci are going to be in between the two branches, okay? We have a conjugate axis. That's going to hold your covertices, conjugate covertices. Then what we're going to do is once we find our vertices and our covertices, we're going to sketch a dotted line box around it, or a very light box, because that's going to help us place our hyperbola arms, okay? Once we get our box, then we're going to draw our diagonals. We can easily find the slope of those diagonals because it's going to be, in this case, if it's horizontal, it's going to be your covertex divided by your vertex, or b over a. One of them will be positive, one of them will be negative, okay? Then, once we have that, then we can draw in our branches of our hyperbola. So the hyperbola are those two purple curved arms, okay? And then this also works for vertical, okay? So let me write the equation of a vertical. So that's going to be y squared over a squared, because it's positive, and x squared over b squared with a minus sign in between equals 1. So here we go. We have a transverse axis. It is now vertical. It has the vertices on it, okay? We also have the foci. Okay, they're going to be towards the ends of that, at the ends of the transverse axis. We have a conjugate axis that has endpoints of the covertices, B, okay? Then we're going to draw a box around those. Once we get our box drawn, then we're going to put in our asymptotes, and notice that our asymptotes are now a over b. So when it's vertical, it's a over b and negative a over b. So you have to remember that it changes when you have a vertical hyperbola. And then what we do is we then trace. See, here's my vertex, so that has to lie on my hyperbola. So watch where my branches go now. There and there. Okay, the branches always go through the vertex. They don't go through the co-vertex. Okay, so let's try just writing some equations before we graph. Get used to some of these ideas, okay? Find the equation of a hyperbola given values of a, b, or c, and then highlight this. It says assume that the transverse axis is horizontal. So that tells us that x squared is the positive term. X squared is positive, has the positive sign in front of it, okay? Not the minus sign, okay? So x squared is the positive term, okay? So this is a and this is b. So that means this has to go under the x squared. So we're going to have x squared over a squared minus y squared over b squared is equal to 1. Now I'm going to plug in. So I get x squared over 64 minus y squared over 9 is equal to 1. Now remember, a squared is no longer the biggest number. It doesn't matter which one is the biggest number. A squared has to go under the positive term. A squared has to go under the positive term. So whatever is the positive term, that's going to tell you whether you have a horizontal or a vertical. Okay, why don't you try the video question? All right, hopefully that went well for you. Let's try another one. Find the equation of the hyperbola with values of a, b, or c. Assume that the transverse axis is horizontal. So again, we're going to have our x squared is going to be positive. Our x squared is going to be positive. But now I'm given a and c, but I need a and b. So I'm going to use this equation to help me find b. So I have 15 squared is equal to 5 squared plus b squared, okay? So this is 225 minus 25 is equal to b squared. So 200 is equal to b squared, okay? So now I'm going to plug everything in. So I have x squared over a squared minus y squared over b squared equals 1. Okay, so that means I have x squared over 25, because that's what a squared is, minus y squared over b squared, 200, is equal to 1. So don't be alarmed because my a squared is smaller than b squared. It's okay. It's okay because this is a hyperbola, all right? This minus sign tells us that it's a hyperbola. We're in the hyperbola section. So it doesn't matter. The size of the denominator is not telling you what a squared is. It's the denominator of the positive term. Do you see how this one is positive? That makes 25 a squared. Okay. Why don't you try the video question? All right, let's try another scenario. Oops. Okay, so find the equation of the hyperbola values from A, B, or C. Assume the transverse axis is horizontal. Okay, so we're still going horizontal, Notice where my foci is. This is C, and it's in the X spot, right? Okay, and so C has to lie on the transverse axis just like A. So here's another reason why a squared has to go under x squared. X squared has to be the positive term. This is a vertice. This is an A. Okay, so now what we're going to do, we have to find b squared. So we're going to use this equation. So I have c squared, which is 81, is equal to 16 plus b squared. When I do that math, I get 65 is equal to b squared. Okay, so x is my positive term, so a squared has to go under that, right? Doesn't matter the size of my denominators for a hyperbola, that's only on an ellipse. So now I have x squared over 16 minus y squared over 65. Well, equals 1. So why don't you try the video question and come on back. Okay, I hope that went well for you. Now we're going to do a little bit of graphing, okay? So we want to find the vertices, covertices, foci, asymptotes, and we want to graph. So first look at your equation and determine whether it's horizontal or vertical. Which one of these variables has a positive sign in front of it? X squared. So that means that this is going to be a horizontal hyperbola. Use a squared equals 9 to find the vertices. So that means if a squared equals 9, then a equals plus or minus 3, okay? And that means that the vertices are going to be negative 3, 0, and 3, 0. So if this is a squared, then this has to be b squared. So we're going to, not because it's smaller, because it's under the negative term. See the negative sign? That's in front of the y squared, okay? So that means b equals plus or minus 2, and that means that b has to go in the y position of our ordered pair. So our covertices are 0, negative 2, and 0, 2. Now we're going to use c squared equals a squared plus b squared, and we're going to figure out what our c is. And so we get 9 plus 4, so c squared is going to be 13, and c is going to be, ooh, that doesn't look good. C is going to be plus or minus the square root of 13, and it has to be on the same axis as the vertex, okay? So let's, so this is going to be, the foci are going to be at negative root 13, 0, and positive root 13, 0. That's a root, okay? All right, and now we're going to find our asymptotes. So look, b, we know what b is, it's 2. So y equals b is 2. So it's going to be plus or minus 2 over a is 3. 2 over 3 times x. Okay, so let's put these down and let's do it in the order that we kind of did it before when we were looking at the pieces on those pictures. All right, so we're going to start by plotting our vertices. Negative 3, 0, and positive 3, 0. Okay, that's my vertex. Negative 2, 0. I'm sorry, 0, negative 2, that's my covertex. And positive 2, 0. Sorry, 0, 2. 0, negative 2. Now what I'm going to do is I'm going to draw my box. The box goes through the vertex and the covertex. Right? My foci is going to be the square root of 13. So the square root of 16 is 4. The square root of 3 is 9. So I'm going to go like in between there. Okay. Now I'm going to draw in my asymptotes. And label them. Y equals negative 2/3 x. And sorry, this should be way up here. And y equals positive 2/3 x. Okay. And now I'm going to draw in. Let me draw it in with a different color. Use red. All right. So here are my branches, just like that. And I don't really even have to plot one point. I mean, I do plot one point. I plot 4 of them, 6 of them, right? But nothing actually, other than the vertex, nothing on the actual arms, okay? And I'm going to let this one be the video question, and so we can go through it tomorrow if you get any of it incorrect. Thank you for listening to my teaching video. I hope you enjoyed it, and I will see you tomorrow. Thanks.